Now we are going to derive the expression for energy of the electron in the nth orbit. Here, when electron revolves in the orbit, they possess some energy. That energy is called En. When electron revolves in different orbit, the different orbit electron, they will possess different amount of energy. The energy of the first orbit electron is different from the energy of the second orbit electron. So, to calculate the energy of any orbit or any electron in any orbit, we have to derive an expression. Usually the total energy of the electron, that is the sum of the two energies. Which two energies? The electron, it possesses the electron and nucleus. In this system, some amount of energy is stored up. That is called electrostatic potential energy. That is represented by Un. Are you clear? In between the nucleus and electron, some amount of energy is stored up, some amount of potential energy is stored up. That is called electrostatic potential energy. When electron revolves in the orbit, this is the direction of the tangential velocity. The electron possesses kinetic energy also. If you calculate both the two energies, that is electrostatic potential energy and kinetic energy of the electron, only then you are able to get the total energy of the electron. Total energy of the electron. So here, first we have to calculate what is the value of electrostatic potential energy, what is the value of kinetic energy of the electron. Later both of them have to be summed up. Only then we are able to get the total energy. So let's go to the derivation part step by step. Listen the thing carefully. To calculate the electrostatic potential energy between the nucleus and electron, this formula must be used. Already you have learned this formula in the first lesson. To calculate the electrostatic potential energy in 2-point charge system, we have to use the formula Q1 Q2 divided by 4 pi epsilon naught Rn. This is the formula. Okay. Now I am going to use the first expression to calculate the electrostatic potential energy. How will you write? Here Un is nothing but electrostatic potential energy. There instead of Q1 we can write it as Ze. This is charge of the nucleus. And then charge of the electron can be written as minus E divided by 4 pi epsilon naught Rn. So this is the expression. Already we have derived the expression for the radius of the nth orbit. This Rn is clear to be replaced by this expression. Are you clear? After replacing this, you will get the expression. So clear? Since the steps are lengthy, I want to reduce the steps. So later you substitute here, you will get the new expression. The expression will be like this. Here minus sign is there, that is very important. Z square m e power of 4 whole divided by 4 epsilon naught square n square h square. This is the expression for electrostatic potential energy stored up between the nucleus and the electron. Are you clear? Don't forget. So the first kind of energy is calculated. What is the another one? The another one is kinetic energy. When it is revolving in the circular orbit, the electron will possess kinetic energy due to its tangential velocity. So the formula is kinetic energy is equal to, that can be written as Ek. Clear? Ken. You can assign any expression. Ken. What is the formula? Half mvn square. Are you clear? Half into m into the Vn is already calculated. Look at that. Vn expression is Hz divided by 2 pi m a naught n. Are you clear? Instead of a naught, I have substituted the clear. Already we have calculated the Bohr radius expressions. Therefrom I have written a naught. After that we have got the new expression for Vn, that is Hz e square divided by 2n epsilon naught h. That expression must be substituted here. Now I am going to substitute the expression of Vn. H z e square whole divided by 2n epsilon naught h. So clear? That one must be squared. After squaring, the kinetic energy of the electron in any orbit can be calculated. So after simplifying, you will get the new expression. The new expression will be m e power of 4 z square whole divided by 8 epsilon naught h square and then n square. So this is the expression to calculate the kinetic energy. Now you compare both. Are you clear? This is the expression for electrostatic potential energy. This is the expression for kinetic energy of the electron in any orbit. Now both of them have to be summed up. Are you clear? How to sum up? Only then you are able to get the total energy of the electron in any orbit. I will write the expression here. Kinetic energy in any orbit plus potential energy in any orbit. Both of them must be added. Here me power of 4 divided by 8 epsilon naught square h square n square can be written. Here it is with minus sign, minus of z square me power of 4 whole divided by 4 epsilon naught square n square h square. Here the common factor is, this is the common factor, 8 epsilon naught square h square n square can be written. If this one is divided by this one, you will get 1. Therefore, me power of 4 you will get. Minus of, if this one is divided by this one, you will get 2. Therefore, 2 z square me power of 4 you will obtain. So, the energy of the nth orbit will be equal to, here you can subtract easily. After that, you will be getting the answer is minus of z square me power of 4 whole divided by 8 epsilon naught h square n square you will get. Understand this? So, this is the expression for energy of the nth orbit. Understood? Here the thing is that my negative sign is very important. Negative sign is very important. Here all are constants. Z is the atomic number of the element, m is the mass of the electron, E is the charge of the electron, 8 is a number, 8 epsilon naught is the permittivity of free space, and h square is nothing but Planck's constant. Okay, so this is the variable factor. In the case of hydrogen, clear, what is the value of Z? Z value can be substituted as 1. After substitution, what will happen? This equation, that one becomes En is equal to, all are constant, no? En is directly proportional to minus of 1 by n square we can substitute. It shows that, clear, when the principal quantum number increases, clear, because of negative sign, look at that, very important. So, negative sign is there, no? That one gives a new idea. When the principal quantum number increases, energy of the electron in the nth orbit also increases. When principal quantum increases, energy of the electron in the particular orbit also increases. Are you clear? So, the electron in the first orbit, it possesses lesser energy. If you go to the second orbit, n is equal to 2. Therefore, principal quantum number increases. Energy of the electron in the second orbit also increases. So, that is the important conclusion that must be arrived. Here, few more things must be clearly understood. I will write certain important expressions, that one will be helpful for you. Here, from this observations, we can write it as the electrostatic potential energy Un will be equal to minus of 2 KEN. Make a note. Sometime kinetic energy value will be given. Clear? To calculate the potential energy of the electron, what you have to do? From this expression, these kind of equations can be easily derived. That is, negative symbol, minus sign is there. Are you clear? 2 times of the kinetic energy with negative sign. That one gives you the potential energy of the electron and nucleus system can be calculated. Are you clear? And one more expression can also be written, that is En, energy of the electron in any orbit can be written as Ke, usually Ke plus Pen, no? Ke plus Pen is equal to total. We can write it as minus 2 Ken. Minus 2 Ken can be written. So, En, energy of the electron in any orbit, will be equal to how much? minus of KEN. By mere calculating the kinetic energy of the electron in any orbit, straight away we can say the value of energy of the electron in any orbit can be given. Are you clear? En is equal to minus of KEN. This expression and this expression both are basically very much significant. By using that, some problem will be asked. So note down the formula. This is the formula. Clear? With the help of this, we are able to calculate the energy of the nth orbit. Understood? All are constant except the principal quantum number. Okay. Now we are going to calculate the energy values of the electrons in different orbits. To calculate the energy value of the electrons in any element in any orbit, this expression must be used. If all the values are substituted, you will get the value in terms of joule. Here m is nothing but mass of the electron, E is the charge of the electron, Z is the atomic number of the particular element, and 8 is a number, epsilon naught is the permittivity of the free space, H is the Planck's constant, N is the principal quantum number. Here all constants must be substituted. Here the only variable factors are Z and N. You can choose any element. For example, if hydrogen is chosen, means Z must be written as 1. Here N is the principal quantum number. Here let us choose the simplest one. We are going to concentrate only on the hydrogen atom. Are you clear? So in this particular lesson we are going to concentrate on hydrogen atom. So let us take it as Z is equal to 1. Hydrogen atom atomic number is 1. Substitute the value. After that what will happen? En is equal to, here after substituting Z is equal to 1, the formula can be altered. It's clear? The answer, energy answer, that could be converted into electron volt also. So this is a main formula, minus 13.6 electron volt divided by, this is the principal quantum number that alone exists in the denominator. So by using this expression, En is equal to minus 13.6 electron volt divided by n square, we are able to calculate the energy of the electron in any orbit can be calculated. Let us take the first one. If usually in the hydrogen atom, the electron that is revolving in the first orbit. Are you clear? When electron revolves in the first orbit, that is called as ground state energy. Are you clear? Ground state energy of the electron. How to calculate the electron in the first orbit? There, instead of n, we have to substitute 1. Are you clear? Principal quantum number is 1. So how to write this? E1 is equal to minus 13.6 divided by 1 square must be substituted. After substitution you will get minus 13.6 electron volt. So this is the energy of the electron in the first orbit of the hydrogen atom. This value is otherwise called as 1 Rydberg, very important one. 1 Rydberg is nothing but energy of the electron in the ground state, that is in the first orbit, may be asked in the examination. Now if the electron, if it switch over from excited from ground level to the first orbit to second orbit, clear, the energy value will differ. How to calculate the electron's energy in the second orbit? Instead of n, we have to substitute 2. Now n is equal to 2 must be substituted. E2 is equal to minus 13.6 divided by 2 square must be substituted, minus 13.6 electron volt divided by 4. So finally we will be getting minus 3.4 electron volt. This is called as ground state energy level, ground state energy. This is called as energy of the first excited state. First excited state. Are you clear? With respect to the electron, if the electron is excited to the next level, the energy of the electron in the second orbit is called first excited state. Its energy value is minus 3.4 electron volt. Now we are going to calculate the energy of the electron in the third orbit. E3 is equal to minus 13.6 electron volt divided by, instead of n, substitute 3 square, you will get minus 13.6 divided by 9. You have to substitute, the energy value will be minus 1.51 electron volt. This is the energy of the electron in the third orbit. It should be called as second excited state. Second excited state. So like that we are able to calculate the energy of the electron in various orbits. The general formula is this one. The minus sign is very important. Are you clear? Here already I have written all the values. The energy of the electron in the first orbit is minus 13.6 electron volt. Energy of the electron in the second orbit is minus 3.4 electron volt. Energy of the electron in the third orbit is this much. If you move from the first orbit to the outer orbit, the energy value increases because of the negative sign. Though the number appears very less because of negative sign, the energy value increases. Okay, very important one. Are you clear? So that is a very important formula.